Today we're going to talk about 7-segment displays. So you have seen these on watches, you've seen them scoreboard in gym, stuff like that. So how do you actually control which one of these segments light up at the right time? So we're going to focus on one of them. So each of these segments actually have names. If you look at a 7-segment display, 7 segment comes from 1, 2, 3, 4, 5, 6, 7. That's 7 segments. Each of these is just an LED. Um, you can light them up by giving them a positive or a negative signal, depending on which type you get. But they are named, we have the A, B, C, D, E, F, and G segments. So when we look, let's go the other way here. Bam, 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 bam. So when you look at the different numbers, 0, all of them but the G segment lights up. When 1, you have the B and C segments light up. For 2, the A, B, D, E, and F segments light up, or G segments light up, and so on and so on. So when you look at these guys, we can look at what should light up or not. So for example, if I want to make the E segment light up, now the E segment would light up on a 0, not on a 1, on a 2, on a 6, and an 8. So 0, 2, 6, or 8. Either one of those. If I want to light the B segment up, that would be on a 0, 1, 2, 3, 4, no, 7, 8, and 9. So how can we make circuits to do that? Let's actually look at that right now. So I have the, let's do the E segment first. I want to light that up on a 0, 2, 6, or 8. So if I go in, I have 0, 2, 6, or 8. I want to light it up on anyone on a 0, or this guy, or this guy, or this guy. So since it works in a digital format, I'm going to use binary numbers, right? So to represent these guys, I have an 8, 4, 2, 1. So 0, all zeros, 2, 0, 0, 1, 0. The 2 is 6, 0, 1, 1, 0. So basically, the 4 and the 2 make 6, and the 8, I have the 8, 0, 0, 0. So basically, on those 4 numbers, I want to light this up. So I have 4 lines coming in. I have an 8, I have a 4, a 2, and a 1. Yeah, my 4 segments. And I'm going to need 1, 2, 3, 4 of these guys. Ooh, okay, I'm going to make it smaller because I need more space. I'm going to go up here. I'm going to go 8, 4, 2, 1. So I need 8, 4, 2, 1, 8, 4, 2, 1, 8, 4, 2, 1. I need 1, 2, 3, 4 sets of them. So I can get lazy. I can write 8, 4, 2, 1, 8, 4, 2, 1, 8, 4, 2, 1. That would be perfectly fine when you guys do it. In reality, what they do is they just branch the wires out. So for example, this is the 8 position, right? Goes up, doesn't connect, doesn't connect, doesn't connect, connects to this guy. The 4, no, connects to the 4. The 2, no, connects to the 2. The 1 connects to the 1. And so on and so on. I can do that over and over again. So the 8 connects to the 8. The 4 connects to the 4. The 2 connects to the 2. The 1 connects to the 1. Or you could write 8, 4, 2, 1. So those are going to be my 4 input lines, right? So I'm going to have 4 cases. I'm going to have a 0. It's going to light up on. It's going to light up on the 2. It's going to light up on the 6. It's going to light up on the 8. Yeah. So the easiest way, again, you would take classes on this if you became an electrical or computer engineer on how to make it most efficient. We are going to just use NOT gate, AND gates, and OR gates, right? So I want to light it up when it's 0, 0, 0, 0. So my goal So this guy is going to be 0, which is 0, 0, 0, 0. This guy is going to be for the 2, 0, 0, 1, 0. This guy is going to be for the 6, 0, 1, 1, 0. This guy is going to be 8, 1, 0, 0, 0. So basically I have 0, 2, 6, 8. So the easiest way always is turn everything into ones. So whenever I have a 0, I'm just going to turn it into a 1 using a NOT gate. Yeah. So I take all of these guys, NOT gate, NOT gate, NOT gate, NOT gate. Okay, so now I have 1, 1, 1, 1, right? If I have a 0, all of these would be 1s. I AND gate them together. Bam. 1 and 1 makes 1. 1 and 1 makes 1. 1 and 1 makes 1. So this circuit gives me a 1 if I have a 0 input. It's the only time it's going to give me a 1. 1 on a 0 input. Okay, so now I do the same for the 2 situations right here. So I come in, anything that's 0, and I use a NOT gate on. If it's 1, I do not need to use a NOT gate on it. So now I have all 1s if I have a 2 input. AND gate these guys together. AND gate these guys together. AND gate these guys together. This guy will give me a 1 if I have a 2 input. Okay. Do the same for this guy. Anytime I have a 0, I'm going to turn it into a 1. Yeah, I have a 1, so 0, NOT gate to a 1. I have a 1, I have a 1, 0, NOT gate at a 1. So now if I had a 6 right here, if I had a 6 input, remember 6, one of the 0, 2, 6, 8, it's going to line up my E segment, right? So my 6, 0, 1, 1, 0, 0, 1, 1, 0. I take all the zeros, use a NOT gate to invert it, and I don't need to do that with the 1s. So now I have, after this stage, I have all 1s on a 6 input. AND gate them together. AND gate these guys together. AND gate the 2 AND gates together. So this guy gives me a 1 on a 6. 1 on a 6 input. So 1 on a 0 input, 1 on a 2 input, 1 on a 6 input, and finally we have the 8 input right there. So I have a 1, the 0, I use a NOT gate, 0, use a NOT gate, 0, use a NOT gate. So now I have all 1s on an 8 input, AND gate them together, AND gate them together, AND gate them together. So now I have a 1 on a 0 input, 1 on a 2 input, 1 on a 6 input, 1 on an 8 input. So I have 0, 2, 6, 8. Either one of them will generate a 1 output with this circuit. Okay. So now how do I combine these guys? I'm going to do it if I have this guy with line up on a 0 or a 2 or a 6 or an 8. So either one of my possibility now, I can OR gate together. If any one of them is a 1, I want to give a 1 output. So I take these two together. I have an OR gate, remember curved back. So flat back for the AND gate, curved for the OR gate. So here I get a 1 if I have a 0 or a 2 input. On this guy, curved back. So here I get a 1 output if I have a 1, 6, if I have a 6 input or an 8 input. So 0 or 2, 6 or 8. Combine these guys. Now I have 0 or 2 or 6 or 8. So this guy, again, if we do it, this guy, 1 output if 0, 0, 0, 0 in, which is 0. This guy is 1 if 0, 0, 1, 0 or a 2 input. This guy is a 1 if I have a 0, 1, 1, 0 input, which is 6. This guy is a 1 if I have a 1, 0, 0, 0 or an 8. So that makes, if I have an OR gate, 1 if basically 0 or 2. So 0, 0, 0, 0 or 0, 0, 1, 0. This guy right here, I have a 1 if I have a 6 or 8. So 0, 0, 0, 1, 1, 0, 1, 0, 0, 0. And on this guy, I have a 1 if 1 or 2 or 6 or 8. So now this circuit right here will control that this one segment lights up, the E segment lights up at the correct time. So on my watch, if we go back to the watch picture, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I don't know if it'll show you, it might be too close, but I basically have 12 of these different segments, right? This controls one of the 7 segments in one of those 12 different 7-segment displays or 7-segment units. So you can imagine I need a lot of them. So again, if we look at this, I have, and a NOT gate is 1 transistor, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 12 NOT gates. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 AND gates. Also, all of them are 2 transistors. So that would be 12 total plus 24 is 36. I have 1, 2, 3 OR gates. And that would be 2 transistors to be 6. So basically, to control this one segment, I would need 36 plus 6, 42 transistors just for that one segment in one of the 12 of these guys. Okay, so that's going to be the D. That's going to be the E segment. Let's do another one. Let me erase really quick. And we're going to see how can I actually use less, right? So check it out. I had 1, 2, 3, 4 inputs, right? I have kind of these 1, 2, 3, 4 groupings that I used. So I have 1 for the 0, 1 for the 2, 1 for the 6, 1 for the 8. 0, 2, 6, 8. Okay, look at the B segments. 0, 1, 2, 3, 4, 5, 8, 9. So the B segment, this guy, right, lights up on a 0, 1, 2, 3, 4, not on a 5, not on a 6, 7, 8, 9. So now instead of having 1, 2, 3, 4 groupings, because I have 1, 2, 3, 4 different numbers, I would need 1, 2, 3, 4, 5, 6, 7, 8 different groupings maybe. So twice as big as this guy. So let's do that really quick. So in this guy, I want to light it up on a 0, 1, 2, 3, 4, 7, 8, 9. Okay, so that makes it a lot of circuits, right? So there's different ways. Remember, we talked about different ways. I mentioned you can kind of, some once in a while, make different circuits to make it easier. So on this case, right, this is the same. I want to light it up on a 0, 1, 2, 3, 4, not on 5 and 6, on a 7, 8, 9. So basically, I'm not lighting it up on a 5 or 6. So I can basically, instead of making a circuit that gives me a 1 on all of these guys, right? I can make a circuit that gives me a 1 on a 5 or 6 and then invert it. So the only time that I get a 0 is on a 5 or 6. I'm going to get a 1 on everything but a 5 or 6. So kind of I'm doing the inverse of what I want. It's going to be a lot smaller circuit. So if I do it this way, okay, I have a 5 and a 6. So I have it on a 5. So I have 8, 4, 2, and 1 input. 5 is a 4 and a 1. 6 is a 4 and a 2. So I want to light it up on a 0, 1, 0, 1 input, or a 0, 1, 1, 0. Or, like really what I do, I don't want to light it up on this, and I don't want to light it up on that. So invert it. So to do this, right, here I go again. I have 8, 4, 2. I'm running out of space, just like I did last time. Let's do it correctly. So I have 8, 4, 2. I'm going to try to make a 4. 4, 2, and 1. Okay. And then I can either like do another one, 8, 4, 2, 1, and write 8, 4, 2, 1. Or in reality, just to show you, really I'm connecting to the 8 wire. I'm connecting to the 4 wire. I'm connecting to the 2 wire. I'm connecting to the 1 wire. So when you look at circuit diagrams, right, see the little like bubble, that means there's a connection between these 2 wires. Whenever I have that little jump, it means there's no connection. And again, had we done a lot of stuff in class like we were supposed to be doing, we would have dealt with all that. That would have been kind of second nature to you guys. Okay, so I have 2 scenarios now. I have the 5, which is 0, 1, 0, 1, and I have the 6, 0, 1, 1, 0. So basically, I do not want to light it up on those 2 cases. So I'm going to give a 1 in those 2 cases, and then I'm going to invert it because it's going to give me a 0 in those 2 cases, which is opposite of 0. Remember, there's only 2 choices, would be a 1. So check it out. So in this case, I'm going to turn everything into 1s. Whenever I have a 0, bam, 1, 0, 1. So now I have all 1s on a 5 inputs. So I'm only gonna get a 1 if I have only a 5 input. AND gate them together. So now I have a 1 if I have 0, 1, or 1, or 0, 1, or 0, 1 right here. And I'm gonna AND gate these together. So now I have a 1 only if I have a 0, 1, 0, 1, 5 input. I'm going to do the same for these guys. I'm going to come in, take this guy, it becomes a 0. 1 is a 1, 1 is a 1, the 0 becomes a 1. So invert all the zeros. I AND gate them together. AND gate these guys together. AND gate these guys together. So now I have a 1 on a 5 input. I have a 1 on a 6 input. OR gate them together. So this guy is 1 on 5 input, which is 0, 1, 0, 1. Here I have a 1 on a 6 input, which is 0, 1, 1, 0. Right here I have a 1 on 5 or 6 input. You can't read that, huh? I'm messing up, all right. So 1 right here in the middle, I have 1 on 5 or 6 input, right there. 1 on a 5 or 6 input, okay? But that's not what I want. I want a 1 on all of these guys, everything except a 5 or 6 input. So all I need to do is put a NOT gate right here. And now I have on this guy, I have a 0 on 5 or 6 input. So every other combination would give me a 1. So basically, if I had a 0, 1, 2, 3, 4, 7, 8, 9, anything but a 5 or 6, I would get a 1. So instead of having 1, 2, 3, 4, 5, 6, 7, 8 of these little clusters of circuits, now I had only 2. So I reduced the number of transistors quite a bit. I simplified my circuit just kind of by knowing that, right? Okay, so for your homework assignment, you have to basically make a circuit to light up the A segment at the appropriate times. So when is the A segment lit up? So you can do it either by, well, I'll let you figure it out. Do the A segment. You can do it using lots of transistors or using less transistors. So check it out, guys. I'm going to show you a couple of things. So if you had been in class, we would have done, this is a, it's hard, yeah, you can hardly see these guys light up. So this guy is a circuit that we do, and because of that lamp, it's really hard to see stuff light up. Let me see if I can, yeah, so you kind of see the LEDs light. So what you would see if like my camera was a little bit better, maybe if there's less light, is here we have a circuit that basically counts 0 to 9 and then back on a 7-segment display. We have a couple of chips that help us do it because the circuit is inside the chips. And then along here, it counts in binary at the same time. So this would have been, had we had normal school, this would have been one of the labs that you guys do. And you can see they did a pretty nice job actually, wiring this up. Can we see them light up? Yeah, you can kind of see 1, 2, 2 and 3 makes 3, 4, 4 and 1 makes 5, 6, 7, 8, and so on. So we would have done that lab in class. So let's go back to real life right here. Pictures. Bam. So inside